A very warm good morning to all my dear students. I welcome you in your science tutorials. Yesterday we have discussed about liquid pressure. Also we have discussed its application. Today we will discuss about atmospheric pressure and we will discuss about its applications. Let's start our topic. Let's start with atmospheric pressure. See beta, atmospheric pressure, the name is telling us that we live on the earth, there is a lot of air around us, and the layer of air surrounding our earth is called atmosphere, and the pressure exerted by the air due to its own weight, it is known as atmospheric pressure. The air in our atmosphere extends up to several kilometers above the surface of the earth. Air has weight, so it creates pressure on the objects below it. So the pressure exerted by the air due to its own weight, it is called atmospheric pressure. Now the atmospheric pressure at sea level is about 100 kilopascals. If such an enormous amount of pressure is acting on us, why do not we feel it? हमें ऐसा लगता क्यों नहीं है? Why don't we feel that this pressure is on our head? This is because the pressure of the blood in the blood vessels and other fluids, क्योंकि हमारी body में भी fluids है ना, so liquid exerts the pressure in the same way. So the pressure exerted by the blood vessels and the other fluids balance the atmospheric pressure. For this reason, we do not feel such a great pressure on our head. Now, we will explain this. We will see this by using one activity to show that existence of atmospheric pressure. What we need to prove that yes, atmospheric pressure exists. What we need to take it? We need to have a tin can, a cork, a Bunsen burner, water and matchsticks. These all things are required. Take a thin walled empty tin can. For an empty tin can, the air pressure inside and outside is the same because there is no liquid inside it, it is empty. Put some water in it. Okay, now what you have to do, you have to heat the tin can with the help of Bunsen burner to boil the water till steam is formed. The steam expels the air from inside the can so that when water is boiling, there is no air inside the can. Now the whole tin can is filled with steam. There is no air. Now it has already come out. So what you will see that the whole tin can is filled with steam. Fit a tight cork. Now we have fit cork on the mouth of the tin can and stop boiling, stop heating. Now pour cold tap water on this can. This tap water comes on can and the can collapses inwards as if large force is acting from outside has crushed it. This is the reason of the crushing the can. Now we will discuss what is the reason for crushing. For an empty tin can, when the can was empty, inside and outside, for a same pressure, when water is in the can, steam pushes the air out, and when water in the tin is boiled, steam pushes the air out. The space inside the can is filled with steam. On cooling, the steam gets condensed to water and the pressure inside the can gets lowered. The lower pressure inside the can and outside the pressure being much greater cannot balance now. So this is the reason that can get crushed. This experiment is showing the existence of a large atmospheric pressure. So this is the activity. Now we are moving to the next activity, that is activity number 8. Now we have to show the presence of atmospheric pressure. We have to take a glass tumbler and a piece of thick card and water. You have to fill a glass tumbler up to the brim of the water. Brim hota hai till the last point. Cover it with a piece of thick card. Press the card hard. You have to press that card hard, showing that there is no air in the glass tumbler. Keep the card in the position with one hand. Invert the glass tumbler. Now withdraw the hand support of the card. What you will see? What you will see? We will see that card does not fall through the glass tumbler that is full of water, exerts pressure on the card in the downward direction. The card does not fall because atmospheric pressure acts on the card in the upward direction, that holds the card in the place. So this activity again shows the presence of enormous atmospheric pressure around us. The atmospheric pressure is maximum on the surface of the earth. See, whenever we go on high mountains, the atmospheric pressure decreases. Sometimes the mountaineers suffer nose bleeding at high altitudes because at high altitudes the atmospheric pressure is much less than our blood pressure. Hence, due to this, some of the blood capillaries burst and blood comes out through the nose of the mountaineers. As astronauts wear a special space suit, this is also for the same reason, to maintain the atmospheric pressure and the body pressure. That is why they wear a special space suit. Now parachutes are used for safe landing. The parachutes blocks the air acting in the upward direction. Due to this, the rate of falling due to gravity slows down and the person lands safely on the ground. So thus parachutes use atmospheric pressure against the gravitational force. So this is all about the atmospheric pressure. Now we will discuss about its applications. What? First is drinking straw. This is a common activity that you have done many times. See, this boy is drinking with this straw. Air pressure is reduced here at the mouth. Fruit juice and drinking straw, atmospheric pressure is at the mouth of the glass. So what we will see, you normally use a drinking straw to drink fruit juice. When you suck air at the upper end of the straw with your mouth, the pressure of the air inside the straw is reduced. The pressure is reduced, but the pressure acting on the surface of the fruit juice is equal to the atmospheric pressure. So the greater atmospheric pressure acting on the surface pushes the fruit juice up into the straw to your mouth. Now moving on to the next, this is syringe. This is another important application of atmospheric pressure. When we dip a syringe in a liquid, see बेटे, हम जब भी syringe है, ये injection को हम fill करेंगे, कोई भी syringe है हमारे पास, when we dip it in a liquid and pull its piston, the pressure inside the syringe get reduced. So the pressure है inside the syringe get reduced. The atmospheric pressure acting on the liquid is more. जो pressure है on the surface of the liquid is more in comparison to the air pressure in the syringe. Thus it pushes the liquid up into the syringe. Now we are moving on to the third application, that is rubber suction pads. These pads are used on the walls for hanging the clothes, calendars and many more items. When good quality rubber suction pad is pressed against the smooth wall, the air between the suction pad and the wall is forced out, reducing the pressure inside. The outside atmospheric pressure, being greater, pushes the suction pad firmly and it adheres to the surface of the wall. See bete, this is the principle behind this. Whenever these suction pads are forced against the wall, the inside pressure is reduced, and from outside the atmospheric pressure allows the rubber suction pad to adhere to the wall. Now we are moving to the next part. Do you know that is atmospheric pressure is measured by an instrument known as barometers. We have mercury barometers called Fortin's barometers and dry barometers. These are called dry barometers because they are without any mercury, without any liquid. They are aneroid barometers and it is used for measuring atmospheric pressure. So this is all about this topic. We have completed our chapter. If you have any query, you can ask. Thank you.